Hey everybody, this video is going to be over synthetic division of polynomials. And what we're actually going to do is we're going to be doing the same division problems that were in the long division video, so that you can see that we're getting the exact same answer with both methods. Now, I do want to specify and kind of, put this out there at the very beginning that synthetic division doesn't always work. Okay, it's a shortcut. It's really just taking the long division process and kind of turning it into an algorithm, a shortcut, to just shorten the process. But it doesn't always work. It only works if we have a divisor in the form x plus c, where c is some number, either a positive or a negative. But the important part here is our divisor has to have a variable with an exponent of 1 and a leading coefficient of 1. For example, I couldn't use synthetic division if I had a divisor that was 2x plus 3, because I have that 2 in front of x. I couldn't use synthetic division if it was, maybe like a 3x minus 1. So anytime you have a coefficient in front of your x term there, we're not going to be able to use synthetic division. It has to be in the form x plus c, where c is just some number. So what you're about to see here is going to look kind of confusing at first, but remember, this is a shortcut, a shortened version of the long division process. So here's our same problem that we had for the long division video. We have our divisor and our dividend here. What we're going to do is we're going to take our divisor here and we're going to set it equal to 0 and solve for x here. The reason we're doing that is this negative 8 we get is going to be an important part of the synthetic division setup. So when we're setting up synthetic division, we're going to have this little box, this little corner here, where we put that negative 8. And then what we're going to do to the right of this is list the coefficients of our dividend. So we're going to do 1, 3, negative 43. Okay, and then give yourself some room underneath and then put a bar. Because what we're going to do next is we're going to take the first number here, okay, and this is always going to happen this way, and we're going to drop that number so that it's underneath our bar here. Then what we do is we take the negative 8 and we're going to multiply it with 1, and the product of those numbers is going to go right here underneath of the 3. Now, we're going to be having these two rows, and what we're going to do is we're going to be adding the numbers from the top row with the numbers in that bottom row. So 3 plus a negative 8 gives us negative 5, and that goes under the bar. So now we repeat, but this time we're doing the negative 8 up here in the corner times negative 5, and the product of those is going to go right here. So negative 8 times negative 5 is a positive 40. We put it here, and then again, we're adding the negative 43 and the 40 together to get negative 3. Now, I know that I'm done with my synthetic division here because I don't have any more columns to go. That was my furthest right column, so that's where I stop. So now we need to interpret our result here. Our answer is really what's underneath the blue bar. Okay, that represents our quotient. But here's how you interpret it with synthetic division. The last number here is always going to be part of your remainder. The number to the left of that is going to represent your constant. And the number to the left of that is the coefficient of x. So if we're writing our quotient, it would look like 1x minus 5 minus 3, and then remember the remainder needs to be put over the divisor, which in this case was x plus 8. And this would be our quotient, which is exactly what we got when we used long division. So let's see another example of synthetic division, because the tricky part here is definitely the setup. Okay, so for this one, remember in the long division video, we said, hey, we're missing a power of k squared. So we had that placeholder of 0k squared. Now that's really important because the synthetic division process uses the coefficients of all of our terms. So we need to have that 0k squared there because it's going to be included when we list out all of those coefficients. So again, we're going to figure out, all right, what number are we putting in our box here? We know the coefficients are 1, 0, negative 17, positive 32. Okay, we know we're going to be adding the rows together. We know our remainder is going to go here. We need to figure out what number goes up in the box there. What number am I going to be multiplying with? So we take our divisor and we set it equal to 0, or the other way you can think about it is we're just going to take the opposite of this. So if we have a positive 5, we're going to use a negative 5 here. So now we're going to take our first coefficient. It's going to drop below the bar. And then we start multiplying. Negative 5 times 1 is negative 5, so I put that here. I add my rows, I get negative 5, and then I repeat. Negative 5 times negative 5 gives me positive 25. I put it here, I add, I repeat. Negative 5 times 8 gives me a negative 40. I add those rows, I get negative 8, and now I'm done. I just need to interpret my answer, okay? Actually write out what my quotient is. So remember, this number here is going to be our remainder. This number is our constant. This number is going to be the coefficient of x, and then we have one more column that we didn't have. This is going to be the coefficient of x squared. So every time you go left another column, your exponent just goes up by 1. So all together here, we can say our quotient here, okay, what we get when we actually do this division is going to be 1x squared minus 5x plus 8 minus 8 over x plus 5. Oh, I just realized I used x and our variable was really k. Let me fix that. So we really have k squared minus 5k, and then this would be k plus 5 in the denominator. And remember, I'm putting that k plus 5 in the denominator here because our remainder always goes back over the divisor. So this right here would be our quotient. And again, it's the exact same quotient we got when we did this division using the long division process. So synthetic division is a very nice tool. It's a lot quicker than long division, but it doesn't always work. It only works if we have linear divisors with a coefficient of 1. All right, guys, I hope this video was helpful. Let me know if you have questions, and have a great rest of your day.